Most galaxies introduce themselves the obvious way, by shining. They sparkle with billions of stars, almost like they're waving at astronomers, saying, "Hey, look over here." But every once in a while, the universe decides to play hide and seek. Recently, astronomers stumbled across what might be one of the darkest galaxies ever found, a ghostly object buried deep inside the Perseus galaxy cluster, about 300 million light-years from Earth. The object has been labeled CDG2, short for Candidate Dark Galaxy 2. And here's the strange part. Scientists didn't notice it because it was bright. They noticed it because something looked statistically suspicious. Think of it like walking into a crowded room and spotting 4 people standing unusually close together in a corner. You immediately wonder, okay, what's going on there? That's essentially what happened in space. While examining old images from the Hubble Space Telescope, researchers noticed 4 globular clusters sitting oddly close to one another. Globular clusters are dense, spherical swarms of ancient stars that usually orbit around galaxies. They're compact and bright enough to stand out even when the galaxy they belong to is almost invisible. So when astronomers saw these 4 clusters huddled together, they raised an eyebrow. Because clusters like that rarely gather randomly. Something massive was probably holding them there, like an unseen gravitational anchor. In other words, the scientists had the cosmic equivalent of footprints, but no visible creature. Curious, and probably a little excited, the team decided to investigate further. They combined Hubble's archival data with deeper observations from the European Space Agency's Euclid mission and Japan's powerful Subaru telescope. That's when the faint glow finally appeared. It wasn't dramatic. No dazzling spiral arms, no brilliant star clouds, just a whisper of light, an incredibly diffuse halo surrounding the 4 clusters. But it was enough to confirm the presence of a galaxy, a very strange one. This galaxy, CDG2, is astonishingly dim. Altogether, it shines with the brightness of only about 6 million suns. That might sound impressive, but in galactic terms, it's practically a nightlight. For comparison, the Milky Way produces the light of hundreds of billions of suns. And here's another odd detail. Those 4 globular clusters alone contribute roughly 16% of all the visible light coming from the galaxy. Imagine 4 street lamps producing a noticeable chunk of the light of an entire city. That's how sparse the rest of the stars are. Which leads to the real mystery. When scientists modeled the mass of CDG2, they discovered that over 99% of it appears to be dark matter. The ordinary ingredients we can see, stars and leftover gas, make up only a tiny fraction of the galaxy's total mass. In other words, this galaxy is almost entirely invisible substance. Now, CDG2 lives inside the Perseus cluster, one of the most massive galaxy gatherings in our cosmic neighborhood. Hundreds of galaxies swarm there, all interacting under intense gravitational forces. It's not exactly a peaceful environment, more like a cosmic demolition derby. In places like this, smaller galaxies can get roughed up. Powerful gravitational interactions and extremely hot gas filling the cluster can strip away their hydrogen. And without hydrogen, galaxies can't form new stars. It's a bit like stealing all the flour from a bakery. The ovens might still be there, but nothing new is getting baked. Scientists suspect that something similar happened to CDG2. Its dark matter halo, the invisible gravitational structure holding everything together, likely formed normally early in the universe. But later, as it drifted through the chaotic Perseus cluster, much of its gas was stripped away before many stars could form. The result? A massive gravitational skeleton, with barely any luminous flesh. Of course, astronomers are cautious. Science rarely shouts, "Mystery solved," on the first try. One remaining uncertainty is whether the globular clusters truly belong to the same galaxy. Without precise measurements of their velocities, there's still a slim chance they only appear close together from our line of sight. But so far, the evidence strongly suggests CDG2 is real and incredibly dominated by dark matter. Interestingly, the discovery doesn't break our understanding of cosmology. If anything, it strengthens it. According to the standard model of cosmic structure, dark matter forms first. It collapses under gravity, creating halos that act like scaffolding for galaxies. Ordinary gas then falls into these halos, cools down, and eventually forms stars. In other words, the visible galaxy is really just the decoration on top of an invisible framework. But in extreme environments like galaxy clusters, that process can fail. Gas can be stripped away before star formation really gets going, leaving behind halos that are massive but nearly invisible. CDG2 may be one of those rare cases, and that's important because cosmological models predict that the universe should contain far more small dark matter halos than visible dwarf galaxies. For years, astronomers have wondered where all those missing galaxies went. One possibility is that many of them never became bright in the first place. They're still out there, lurking in the dark, almost impossible to see. Galaxies like CDG2 might be part of that hidden population, cosmic structures that exist gravitationally but barely glow at all. Which means the universe could be filled with far more galaxies than we can actually observe. A little unsettling if you think about it, because it suggests that the night sky isn't just full of stars we can see. It might also be crowded with galaxies quietly hiding in the dark. Now here's where the story becomes even more interesting. The way astronomers found this galaxy is almost as fascinating as the galaxy itself. Normally, scientists locate galaxies by spotting the soft glow of their stars stretching across space. It's the classic method. Find the light and you find the galaxy. But with CDG2, that approach would have completely failed. The galaxy is simply too dim. So instead, researchers used a clever workaround. Rather than looking for starlight, they looked for globular clusters acting like cosmic breadcrumbs. These clusters are tightly packed spheres of ancient stars that often orbit galaxies like loyal companions. And unlike the faint haze of a dim galaxy, globular clusters are compact, bright, and stubbornly long-lived. They're basically the hardy survivalists of the stellar world. So if you see several of them gathered suspiciously close together, chances are they're orbiting something, even if that something is barely visible. That's exactly what tipped astronomers off. Those four clusters were essentially pointing at an invisible gravitational center like four flashlights aimed at the same object. If this detection strategy continues to work, it could open an entirely new way of finding ultra-faint galaxies that would otherwise slip past our telescopes unnoticed. Instead of searching for galaxies directly, scientists might track their orbiting star clusters like detectives following clues. But before things get too dramatic, it's important to clear up a common misconception. CDG2 is not a completely dark galaxy. It does contain stars. The globular clusters are real, and there are faint stars scattered throughout the system. A truly starless galaxy, one made entirely of dark matter and detectable only through gravitational effects like gravitational lensing, remains purely hypothetical for now. CDG2 sits right on the edge of that idea, but it doesn't quite cross the line. Still, its mass-to-light ratio is so extreme that it stands as one of the clearest real-world examples of a galaxy where dark matter overwhelmingly dominates the structure. Rather than breaking our current understanding of cosmology, it actually reinforces it. It shows that dark matter halos can survive even when the normal process of star formation almost completely fails. Of course, astronomers aren't declaring victory just yet. The next step is confirmation. Scientists want to measure the spectra of those globular clusters, which would allow them to determine their velocities. If all four clusters are moving together within the same gravitational system, that would confirm they're truly bound to CDG2, and it would make the galaxy's mass estimates far more precise. If that happens, CDG2 could become something like a prototype, the first well-studied member of a whole class of extremely dark galaxies. And that possibility is where things start to get exciting. New sky surveys, particularly the Euclid mission, are designed to map enormous portions of the universe and trace dark matter through its gravitational effects. When those large surveys are combined with deep, targeted observations, astronomers may start uncovering many more faint galaxies hidden inside dense clusters. If systems like CDG2 turn out to be common, it could solve a long-standing puzzle in cosmology. Computer simulations predict that the universe should contain far more small dark matter halos than the number of dwarf galaxies we actually observe. For years, scientists have been scratching their heads over this mismatch.
But what if many of those halos simply never formed many stars, or lost their gas early? In that case, they'd still exist, but they'd be almost invisible. Galaxies like CDG2 could represent exactly that missing population. There's also another intriguing angle here: dark matter physics itself. By carefully mapping how mass is distributed inside CDG2, astronomers can test whether it matches the predictions made by cold dark matter simulations. If the internal structure looks different than expected, it might hint that dark matter behaves in ways we don't fully understand yet, or that extreme environments like galaxy clusters reshape these halos more dramatically than models predict. And perhaps one of the most interesting lessons from this discovery is methodological. CDG2 wasn't revealed in a single dramatic photograph. There was no moment where a telescope snapped an image and everyone gasped. Instead, it emerged slowly through a combination of archival Hubble data, new survey observations, statistical analysis of cluster positions, and careful cross-checking between multiple instruments. In other words, it was less like finding treasure with a metal detector, and more like assembling a cosmic puzzle piece by piece. Looking ahead, astronomers are likely to keep pushing the limits. They'll search for galaxies that formed even fewer stars, or perhaps systems where the stellar population is so tiny it's almost non-existent. Finding one of those would bring us closer to something extraordinary, directly mapping dark matter structures themselves, rather than the stars that usually reveal them. CDG2 doesn't solve the mystery of dark matter. It doesn't tell us what dark matter particles are or how they interact. But what it does provide is something equally valuable: a visible outline of the invisible. A reminder that most of the universe's structure isn't made of the shining stars we see, but of a hidden framework quietly shaping everything around it. And if CDG2 is any indication, a large portion of that hidden universe may still be waiting in the dark, just beyond the reach of our current telescopes.